bit background, and then just give us a general career talk, please.
Of course. Thank you, Natasha. Thank you, Mel. My name's Ian Palmer. I'm really pleased to have this opportunity today from Croydon Commitment to share with you my career path, as you just heard. So over the next 15 minutes or so, I'd like to give an idea of what a professional engineer does. I'm going to share my story of how I ended up as a professional engineer at McDonald's here in Croydon. Tell you why I enjoy working there as an engineer. I'll also describe the skills that engineers need. So I'm speaking from my experience, so I'm not here to sell the engineering profession. But before we move on to questions at the end of my story, I'll let you know where you can find some more information if you're thinking about a career in engineering or you know somebody who is. And I'll share those websites with you, Natasha, just so you can share them with everybody at the end. So let's start with, what is a professional engineer? Well, the easy bit to explain is the engineer. So it's from a Latin word, which is to create, generate, or devise. So engineers are people who design, build, and maintain engines, machines, and structures. So the tricky bit is the professional part. So the professional part actually means that you've met certain standards and you're listed on a national register. So once you've achieved that registration, it means that you can use certain letters after your name. You may have seen some such as Eng Tech, iEng, CEng, ICT Tech. Basically just means that you're a professional engineer and you're on the register. So in the UK, there's over 250,000 professional engineers and technicians on this register. And every single one of them is a member of one of the 39 professional organisations that look after the different types of professional engineers or technicians. So these organisations that were established over 200 years ago in some cases cover all sorts of industries and roles, such as the traditional engineering disciplines like mechanical, chemical, structural, and civil engineers. But it also includes many new or niche groups that include fire, explosives, IT, nuclear, and acoustics engineers. I'm a professional civil engineer, so I'm a member of the Institution of Civil Engineers. So I specialise in bridges and infrastructure. So just think of the big pieces of concrete and steel that's needed to support our transport systems. So how did I end up as a professional civil engineer? Well, I grew up in the Midlands, I went to state school, but I was always keen and pretty good at maths and physics. So after GCSEs, I did A-levels in these subjects. I didn't really have a plan what to do after A-levels, but I wanted to travel. That was one of my key passions. So I worked a year in Tesco's. I saved up for my travels, while most of my friends went off to university. During that year, I visited them and thought, hey, this is fun. So I thought, well, maybe I'll have a go at going to university. So I looked into what courses I could do. So I had 2 A-levels in maths and physics, but I also wanted a course that would give me opportunities when I eventually went to work to travel. And engineering was the answer. But as I just mentioned, there's loads of different types of engineering. What would I do? Computing, mechanical, electrical, transport planning, aeronautical. The list is long, but I guess as a keen backyard pond builder and a Lego fan before that, civil engineering interested me the most. So I applied and I got accepted to study civil engineering at Aston University in Birmingham. The course was a sandwich course, and that means that I did 3 years full-time at university, but I did 2 7-month industrial placements during the course. So they happened over the summer terms and the summer holidays. I really enjoyed the industrial placements. So seeing, doing, and hearing what you learned about in lectures made it easier for me to understand and remember. Plus, I earned a salary, so that helped pay for the next term's rent. During my first industrial placement, I had my first taste of bridge life. So I worked on the construction of the second Severn Bridge, which is a 5.2 kilometre long crossing that links the west of England to the South Wales across the Severn Estuary. Purely by luck, I worked on the biggest construction project happening in Europe at that time, And what a great job it was. When it opened in 1996, every time my mum crossed the bridge, she'd tell the toll collector that her son built it, which, well, it wasn't strictly true. I was only there for 7 months and had the help of 500 other people. I still think it's a really nice story, and it's nice the bridge will be on this planet way longer than I will. My second placement was building a tram line in central England called the Midland Metro. Again, I love the idea that people get to see friends and family, they go to work, perhaps go out to a football match or a day out much more easily than before, and in comfort and sustainably. After 4 years in total at university, I passed my final exams and got a job building landfills. This was perfect for me. I got valuable construction experience and I got to travel around the UK. Okay, perhaps not to the most glamorous of places, landfill sites, but it did allow me to save up for my next trip, which was for 9 months in Australia. On my way there, I stopped in Hong Kong, and one of the many sites I went on to see was the construction of the current airport. So basically, engineers cut off the top of a mountain that was sticking out of the sea. They used the rock that had cut off to build a flat island and built the airport on top. And to get to the airport, you have to cross one of many bridges. My favourite one was one called Tsing Ma Bridge, which is a suspension bridge, which is almost a mile long, 1.4 kilometres long. So I got the bus out to the construction site, stood at the side of the road, and watched this mega structure being built. From where I was, so far away that you couldn't even see any humans. So it just looked like this bridge was being borne by these machines and cranes and boats. Anyway, I finally got to Australia, and again, I worked with my skills I learned from university and working on the landfill sites, working in a soil laboratory, testing soil as part of the Sydney Olympics construction works, before I went on my travels around Australia by bus. Anyway, when I eventually returned to the UK, I worked for a year assessing bridges in Birmingham before moving to McDonald's Bridge Department here in Croydon in 2000, where I've been working for 22 years. I was at McDonald's where I started my formal professional training. As someone who had moved around so much, I was surprised myself I'm still at McDonald's today. But I think the reason is pretty simple when I thought about it. McDonald provided me with great training, and the company has a really nice family feel, which I think is due to being an employee-owned business, which means that every single one of us who works here owns a tiny piece of the business. So we're all working together for the success of our company, and we choose to do whatever we like with the profits that we make. And as a nice twist of fate, my mentor, who looked after me when I joined McDonald, was one of the designers for that bridge in Hong Kong, the Tsing Ma Bridge, which I stood and watched being built. So I think it really is a very small world in engineering. As I mentioned at the beginning, I'm a bridge engineer, I'm a bridge specialist. So I'm involved in designing new bridges and assessing old bridges to make sure that they're safe to continue to be used. I also get involved in significant civil engineering structures for big schemes, and also get involved in looking at options for new works. For example, at the moment, there's lots of schemes going on to look at reopening of old railways or converting existing infrastructure for a new use. I'm also responsible for the next generation of McDonald's bridge engineers who are starting out on their professional training, but also helping the wider team to make decisions to reduce the energy embodied in their designs to help combat climate change. So I'm always very busy, but I really enjoy my job and working at McDonald. So just a couple of minutes to say, well, who are McDonald and what does McDonald do? So starting with the second question, what do we do? Well, that can be answered in 3 words: engineering, management, and development. And who are we? Well, we're a multinational company with our roots dating back to 1888, when Basil Mott and others formed a partnership to design the tunnels for the City and London Railway, which we now know as London Underground's Northern Line. Today, McDonald has around 12,000 people working in 50 countries, and the biggest number of our team are based here in Croydon, which is our headquarters. We get involved in lots of different jobs, many in engineering across our 6 core sectors that are advisory, the built environment, energy, international development, transport, and water. We work on some really cool projects that honestly change people's lives, the world around us, also using our engineering skills to help combat the climate emergency. Some examples of our current and recent projects can be found on our website, which we'll get Natasha to send the link to. It's just motmax.com. So we continued on, for example, continued with our link to the Northern Line. So we recently designed the extension of the Northern Line for London Underground. We designed a series of ponds in New York to catch polluted water before it ended up in a creek and ultimately sea. And we've helped develop a tool that allows governments to plan their future energy supplies, to investigate the best options to reduce emissions while meeting an ever-growing demand for energy. So giving people the tools to be able to make the right decisions. So what skills do you need to become a professional engineer? So if you cast your mind back to the beginning and remember the origin of the word engineer is to create, generate, or devise. So you need these skills to enable you to design or build or maintain engines, machines, or structures. So to do that, you need a very pragmatic, logical, but flexible mind to be able to spot and solve problems, both big and small. We also need to work to strict standards. I'll share with you an example to try and explain what it is that an engineer does. This is an example from a project I'm currently working on, which is designing a new railway station where the platforms are being built on the top of an embankment. So it's an existing railway line on an embankment, and we're building a new station. I'll show you a picture of it at the end, an artist's impression at the end. So to get to the platform from the car park, there needs to be some stairs. And these stairs are going to be about 18 meters long. So standards tell me the size of the steps so they're safe and comfortable to use. The stairs need to be strong, so mainly made from steel. But the site is near the sea, so we don't want to have to keep repainting the steel to stop it from rusting. The site is remote, so the stairs need to come on a lorry that can't be more than 4.9 meters high, 2.9 meters wide, and 18.6 meters long, including the cab. The stairs need to use as little material as possible to minimize the energy used and to make the component to minimize the energy used to make the components and save money. We also need to install CCTV, lights, speakers to make sure the stairs are safe and secure. And we need the stairs to look nice. So we need to clad it with something that doesn't add too much material or increase the fire risk. And finally, we need to be able to install the stairs with a crane. So lots and lots of different requirements there. You can imagine that even for this simple structure, all these small problems need solving, and how you solve one problem will impact the decision for the other problems. So for example, if we designed a super carbon efficient structure, it would be a single piece, which would be too big to transport. It'd probably be too heavy to lift. And it also needs to be painted regularly to stop it from rusting because it's got the minimum amount of steel that's needed. Or we could design a smaller single piece stair in a different material, which could be transported and lifted. But then it probably wouldn't meet standards because the stairs would be too narrow and the structure would be too bouncy when people use them. So solving problems such as this is something I really enjoy, and it's the reason why I love being a professional engineer. So how do you become a professional engineer? Well, as all careers, you need to maintain and meet a certain education standard, which is relevant to the area of engineering you're interested in. But there are lots and lots of different ways to achieve this. So the traditional route for a professional civil engineer is to get A-levels, usually in maths and physics, although today things like coding and environmental science would be really useful. Then go to university before getting employed, where they'll then typically train for another 5 years or so before taking their professional review. If they pass the review, then you become registered, and at that point you can call yourself a professional chartered engineer. But there are lots of other routes also. There's a degree apprenticeship. This is where you attend college for 1 day a week and you'll work for the other 4 days. After 5 years, and assuming you make the grades, you get your degree, and you can also then take your professional review. If you pass your review, again, you can get registered, call yourself a professional incorporated engineer. Others spend many years working and learning on the job. And again, if they can demonstrate that they meet the educational standards and have the required experience, you can also sit a professional review. And again, assuming you pass that professional review, you can get registered. Depending on what level you go to, become a chartered or incorporated engineer. But it's not all just about engineers. So some of the most important members of our team at McDonald's are technicians. So these are the team that usually work in computer-aided design, or CAD, and they build complex and detailed digital models of the designs and produce the models, images, and drawings that are needed throughout the life of a project. It's the technicians actually that normally get the wows when people use and see their work, whether it's a digital model of how the finished project will look, and I'll show you the one of the railway station in a minute, or more commonly now, it could be a digital model that you can walk around wearing a virtual reality headset. But the technicians, they follow a similar path to the engineers, often training on the job while going to college part-time before sitting the professional review. I must say that what I've shared to you, albeit very quickly, is what I know as a professional civil engineer. There are many, many other ways to become a professional engineer or technician in the other 38 different disciplines. The engineering institutions or the engineering council who maintain the register of engineers are really good places to go for more information if you're interested. But before I stop talking and give you a chance to say something or ask some questions, what I will say is that if you have the skills and the desire to be an engineer or a technician, please go for it. There are many ways to meet the educational standards and to get the training required. So don't look for barriers not to do something. Please do go for it. Well, I'd just like to say thank you for listening. I hope this was interesting and gives you an idea of what McDonald and a professional civil engineer does. I can see there's 3 comments in the chat, but I'm more than happy now to take any questions you may have.
That's great. Thanks very much, Ian, for sharing that. And I use that bridge you worked on a lot as I have family in Wales. And now every time I go over it, I will be thinking of you, which actually brings me to another bridge, and it just out of interest, really. Did you work on the wobbly Millennium Bridge? I mean, what happened there? Because that's stuck in my mind. That's a
brilliant example of engineering. So we have very strict standards which we have to comply with, but it's not a law, it's best practice. And what happens is, as people keep pushing the limits of technology, using computers perhaps, at a certain point the standards, which were written many years ago, they've not caught up or couldn't have anticipated how we're then going to build our structures. So it got to the point where the standard was no longer valid for the particular type of detail that got built.
Okay.
So that's the main reason why it started to wobble. But I guess the ingenuity, the engineers were then, when they realized what the problem was, it was how quickly they were then able to come up with a solution to stabilize the bridge, which, well, it was done and it's still in place today, and I don't believe it wobbled.
I just wondered if it was built with a wobble in mind, just to kind of make it another must-do on the tourist trips to London.
I'm sure somebody involved must have said it was.
Okay. Please do either come on camera if you want to show your face and to interact more visually as well, or if you don't fancy doing that, then please just use the chat function, or raise a hand, because you might as well take advantage of Ian being here now. I was just really way more interested than I thought I'd ever would be. I mean, being somebody who's been in the performing arts and a bit less inclined towards the I suppose the maths and science side of things, actually I realised how much creativity there is in doing what you do. And also when you put it in that sort of solving puzzles, solving things, which I also actually really like doing, that just kind of really sort of grabbed me. I didn't realise it was, it was sort of problem solving to that extent. And I'm guessing that particularly today with all the carbon footprint, that's almost probably taken over as one of the primary things you have to think about. I mean, has that made a significant difference now, or has engineering always been about looking at the best ways of what's the word, of using materials?
Yeah,
I mean, I suppose from this point of view.
So how I try and sell it to my team is, for the last 150 years, people have always used pounds, euros, dollars, yen as the currency for working out if something's affordable. So you've always tried to minimize material because it meant the project was affordable. And I think carbon is just going to be the new currency. So rather than focusing purely on money, and the two are very closely related, there's not a lot between the two. If you can reduce materials, reduce carbon, you're generally going to save money. But I think carbon's going to become the new primary currency that we talk about when we're talking about schemes. But it's certainly at the infancy in what it means to a day-to-day engineer, if I'm honest. But the amount of resources and focus and attention on reducing carbon in everything we do, whether it's going to a meeting or whether it's designing a new scheme, it is at the forefront of decisions. Safety, being affordable, and carbon. They're the three things that every single decision we now make. Again, it's puzzles. You've got to balance. So it's not always going to be the lowest carbon, because there might be other sustainability benefits from something. But at the end of the day, we're in a climate emergency. If we don't do things now, we're going to be in an even worse place and even more trouble.
So do you have somebody now on every project who would look at the carbon footprint, the sustainability, and I mean, it seemed to me that, looking at the supply chain and looking at the personnel and looking at all the ways of working out, there could be numerous ways of working something out like that. If you use a bit of steel there instead of a bit of bamboo, but then the cost of getting the bamboo, those sort of variations.
Absolutely.
And
Yep.
variables.
So
I mean,
so we have calculators and templates. So that's one of the things we've been doing this year in our bridge team. And that, so like you say, a piece of bamboo will have a carbon value associated with it, which includes growing the bamboo, chopping the bamboo down, putting it on a boat, sending it over from where it was grown, processing it, testing it, installing it, taking it back down, getting rid of it. So we know that for 1 ton of bamboo, it's got a number of this much carbon equivalent.
unless of course you're in, say, China or Malaysia or something.
Exactly.
Yeah.
So and in fact, that's some of the work we're doing next year with the university in Madrid, is looking at what the impact is depending on where you are in the world. So while solution A might work in the USA, B might be more effective in the UK, and C in South Africa. It's all very interesting. But yeah, we literally do work out for what we do, use this calculator, how much carbon's embodied in it. So at the moment it's been quite you've looked back at things. This is how much was in it, this is how much is in my design, whereas now we're moving very firmly into this is how much it is at the moment, so what can I now do to make that smaller? And that's the phase we're in at the moment.
So getting back to your stairs, Is that something that you're looking at the moment, and how that would work with your sales and training?
We haven't. That's being built now, but we know
Right,
what's in
okay.
there, and we've just generally tried, because of all the other, solving all the weight, the costs, the lifting, the transport. That's generally why it'd be difficult, I think, but certainly not impossible to reduce it. I'll be surprised how much you'd save if it was significant. But yeah, that's where the industry's heading. The industry, it's not what McDonald's, it's the industry.
Yes, of course. Yeah, I mean, it seems to me quite mind-boggling what people like yourself and are going to have to go through and look at now, with all the impact of building development, all that on the world. And also, I mean, it just came to me as you were speaking about bridges, about that awful accident which happened in Italy not so long ago with the bridge. And is that something that really it should have, like safety and people looking back on previous works, is that an exercise in itself, or is that a part of another team?
So in the UK, not please, everything I say, it's my opinion. I'm not speaking for an industry or McDonald's, but basically the UK is in not a bad place. We spend, the Highways England, or National Highways, I think they're called now, Network Rail, Underground, all the big infrastructure owners, they have a huge task and budget to go out and inspect and assess all of their structures to make sure they're safe to use. And sadly, lots of places where they don't quite have that rigor. You mentioned that sad collapse in Genoa. There's been some very high profile collapses in the United States where they don't have that culture of going out, inspecting, assessing. They've not spotted things that sadly have ultimately led to collapses. So a lot of our work is inspection and assessment work. You think some of our railway bridges are 150 years old and still taking hundreds of trains per day. And a lot of our work is, again, it goes back to that sustainability point of view. The best thing to do is nothing if you're going to stop climate change. So if you've got a bridge that's 150 years and somebody can sit in an office for 6 months doing some maths, doing some modeling to show that actually if you just strengthen this part or take a bit of a load off there, you don't have to replace that bridge, then one, it doesn't disrupt the people that use the bridge, and also it means that you're not adding to the CO2 in the environment, because you're reusing what's done. And that's a huge part of what an engineer does, challenging, do we need to do something? Could we strengthen it? Could we reuse something?
I know, because I mean, looking around London, for a number of years, you just see buildings just coming down and down and down, and you just wonder, don't you, is there some way they could just be left up, or
100%.
I think obviously it looks like it's going more that way, but thanks very much, Ian. That's been a really interesting talk. I've enjoyed it. I hope everybody else here has enjoyed it. Do get in contact with us if you want to find out a bit more. We can put you in touch with people who perhaps have a little bit more information about the different kinds of engineering you could do. This is the last opportunity to ask a question. So whilst we're launching a poll, I think we've got a poll, have we, Natasha?
No, it didn't work for some reason, unfortunately, today.
Okay. Well, anyway, we don't have a poll. It doesn't matter. But please do ask Ian a final question if you need to, because we'll be signing off now. And thank you very much, Ian. Really appreciate the time. And I do know that McDonald's has been one of our business partners for a number of years, and actually we work out of their offices, so they've been good guys letting us use their offices, and they are brilliant. They do their CSR, their corporate social responsibility. We know because we've seen some of their annual reports and what they're doing across the world. I mean, things from toilet twinning, which we have pictures of toilets in, I don't know, Nepal, is it, and other places, Ian, to just being great employers rather. Thanks very much. We'll sign off now. Thank you everybody for attending. Bye for now.